Hello, everybody. Welcome you to all you, our lovely and awesome and great mindsetters. Yes, we are back at it. It is Learn Extra Live. We are back on your TV screens. Hope you guys didn't miss us too much. And now we've got the grade 10 mathematics show. Guys, I'm so happy to be back with you guys. And my name is Queen Matoso. But of course, as always, I'm not rolling alone in this lovely studio. We've got the awesome teacher in studio with us, Natasha. How are you, Natasha?
I'm very well, Queen, and mine says it's great to be back on this live show on a Monday afternoon, and I hope you're all eager to learn. Today, grade 10s, we are looking at an introduction to probability. Yes, Queen.
Wow, guys, already, back with a bang. Probability. I know I had a bit of a problem with that when I was in grade 10, but that's why we have Natasha and we have Mindset Learn here for you guys to help you and equip you get ready for those upcoming exams. The days are just becoming shorter and shorter, and they're so close, they're so nearby. But don't worry, we're here for you as Mindset Learn, and that's why we've got Natasha with us in here today that's going to help you guys through this chapter that I found very difficult, but I'm sure that you guys are going to find such a breeze. Now, guys, remember that we also have our competitions back with us. Yes, it's the Get Connected competition. We still at it. Now we've got our 6 final teachers that you guys have voted for. Now, if you forgot how the procedure works, let me quickly put you through it. Remember that you just go onto Curio and then you register with Curio, and then on Curio you can vote for your final teacher that you like, and we've got the 6 final teachers on the page right now, so you guys can also simply just like on the Facebook page as well the teacher that you would love to win this competition. Remember now that not only do you get to stand yourself a chance of winning 55 Rand Vodacom airtime, but your favorite teacher is also going to get a little young something for themselves, and we'll be announcing the winners, 10 lucky winners, next week. So you guys have to stay tuned, get voting, like the pictures of the favorite teacher that you would like to win this competition. And yes, so without wasting any more time, Natasha, let's get straight into the show.
All right. Okay, Queen. So, mindset is everyone. Hope you're ready and you're ready to enter your competitions, but more than that, you're ready to learn. That's what we're here for, okay? So, today we're going to specifically calculate probabilities. We're going to look at unions and intersections, and we're also going to have a look at Venn diagrams. But before we do any of that, a reminder of your challenge question for today. All right, we are told that the names of each of the 12 months of the year are written onto 12 identical cards. The cards are then placed in a box and the box is shaken. One card is drawn and then replaced. Importantly, the card is replaced. Question A, write down the sample space S in set notation. Question B, part 1, write down a set to represent the following. And the first thing you've got to represent is event A, which is drawing one of the first 6 months of the year. Then part 2, event B, drawing a month beginning with the letter J. Part C, represent S, A, and B by means of a Venn diagram. Okay, so your entire sample space with events A and B in a Venn diagram. Part D, write down the probability of the month drawn starting with the letter J and not being one of the first 6 months of the year. Part 2, the probability of the month drawn being in the first half of the year and starting with the letter J. And then part 3, the probability of the month drawn not being one of the first 6 months and not beginning with the letter J. All right, guys, so hopefully by the end of the show you will all be able to answer it, but I'm hoping even more that some of you will be able to answer this now before you even get any guidance from me. I'm hoping that you guys have learned quite a bit at school and you will be able to answer this. So let's get straight into the lesson for today. Just a reminder firstly of what a probability is. Probability values will always lie between 0, which means it's impossible that that specific event will happen, and 1. 1 means it will definitely happen. Okay, so for example, the sun rising definitely happens every day. All right, so that probability would be 1. So an event that is impossible, again, has a probability of 0. and an event that is certain has a probability of 1. So certain means 100% that's going to happen. All right? Some of the terminology that you guys should be familiar with at this stage: an experiment. An experiment refers to an uncertain process. So you don't know what the outcome is. It's an uncertain process. So an example here would be tossing a coin. That's your experiment. Okay, so tossing a coin would be an example of an experiment. An outcome of an experiment is a single result of that experiment. So if you toss the coin, one of the possible outcomes is you could get a heads. All right? You could get a head on the toss of the coin. Your sample space, the sample space of an experiment is the set of all possible outcomes of that experiment. So guys, you know that if you toss a coin, only 2 possibilities. You could get a head or you could get a tails. All right, that would be the sample space for our example, which is tossing the coin. The sample space is denoted with the symbol S, and the size of the sample space, which is the total number of possible outcomes, is denoted with N. S. All right, so that's your total number of possible outcomes. An event is a specific set of outcomes of an experiment that you are interested in. Okay, so your event could be the event getting a heads on the toss of your coin. All right, that would be one of the events that you could be interested in. An event is denoted with the letter E, and the number of outcomes in the event with the number of outcomes of E, N, E in brackets. All right? When all the outcomes of an activity are equally likely to happen, you can calculate the probability of a specific event E occurring by using this that you all should be familiar with. The probability of event E is the number of favorable outcomes divided by the number of total possible outcomes. So, for example, the probability of me getting a head on the toss of a coin would be 1 over total number of possible outcomes, 2. All right. Unions and intersections. All right. So this is leading you now to Venn diagrams. The union of 2 sets is a new set that contains all the elements of at least one of the sets. So you're all familiar with these diagrams, I hope, by now. All right, so I'm going to put that down. I'm going to have letter A to represent event A and then B. All right, and the union of the 2 sets will be a new set. So A union B, it's a new set that contains all of the elements that are in at least one of the 2 sets. So if we had to draw this, if we had to picture what's going on, so we're going to have all the information that's in at least one of the sets. Okay, so it's the combination of both of them, and you obviously will not repeat any of the elements. So that would be the union of the 2 sets. Your intersection, so the intersection of A and B, that's going to be a new set again that will contain all of the elements that are in both sets. So that would be where the 2 intersect. All right, you're interested in that bit there. Where they intersect, that will be the intersection of A and B, written as A intersection B. Okay. All right, so guys, what we're going to do is we're going to go straight into this first question. We've got quite a lot of examples to get through. Hopefully we'll be able to get through this entire question before break, but if not, we'll continue when we come back after the break, but let's get straight into it. Question 1, cards numbered 1 to 10 are placed in a bag and a card is drawn at random. Okay, random, that means each card has an equally likely possibility of being chosen. The first question is give the sample space N. So your sample space, you're going to list all the possible outcomes. All right, so our sample space, we've got cards numbered from 1 to 10, so we can choose anything from 1, 2, 3, 4, and I'm going to write the whole thing down because we will need it in for the remainder of the example. 5, 6, 7, 8, 9, and 10. So that's your sample space for this question. All right, they then say, part B, represent the event P, and P is now the event where you draw a prime number. Now, obviously, in order for you to answer this question, and as we always say in maths, everything you learn, you never learn in isolation. So, prime number, if you want to draw a prime number, you first obviously need to understand what a prime number is. And remember, a prime number only has two factors, the number 1 and the number itself. Okay, so if we're looking from 1 to 10, the event P is drawing a prime number. So I'm going to say event P is going to be the prime numbers I can choose from here. So it's going to be the number 2, 3, 5, and 7. Those are all your prime numbers. They only have two factors. So event P is 2, 3, 5, and 7. All right, part C. Okay, this says list the event F of drawing a factor of 10. So what numbers can divide into 10? We're restricted from, remember, we're only going from the number 1 to 10, and we want to know which one of these numbers or which of these numbers can divide into 10, the factors of 10. So your factors of 10 from this sample space would be the numbers 1, 2, 2 goes into 10 5 times, 5, 5 goes into 10 2 times, and then 10 itself. Okay, so if factors of 10 would be 1, 2, 5, and 10. Okay, great. Let's move on to part D. List the event P union F. Now remember from the previous slide, P union F, it's a new set that contains all of the elements in at least one of these sets. So list the event P union F of drawing a prime number or a factor of 10. So each and every element needs to be represented here. So we want the union of the two sets that we've just wrote down previously. So P union F, you will not repeat any of the numbers that you have. Okay, so P we knew were our prime numbers. It was 2, 3, 5, and then F was all the factors of 10. So we're going to start in ascending order. So we're starting with the smallest number. We're going to have 1, 2 is repeated. We don't write it down twice. We simply write it down once. And then 3, 5 repeated, so we again only list it once, 7, and 10. All right, so here we've got all of the prime numbers and all of the factors of 10. Okay, that's the union of the two sets. And then lastly, they say represent P intersection F. So what are they talking about here? Right, you want the intersection of the two sets, so the number that's, or the numbers that are common to both of these sets. You can simply look at the numbers that you've got listed in part B and C. Let's identify the common numbers in P and F. We've got 2, which is a prime number, and we've got 2 also as a factor of 10, right? We have 5 being a prime number, and we have 5 as a factor of 10. So therefore P intersection 5 is going to be the number 2 and 5. All right, so P intersection F is going to be 2 and 5. Okay, great. And that was quite well timed, just enough time before we take a break. Guys, I hope you're all with me. And if you're not, please make sure that you send Queen a message so that she'll let me know and I can then help you. Over to you, Queen.
Yes, guys, remember that we are here for you. You can communicate with me via Facebook, via Twitter, or you can also catch yourself some notes on our website, and that is at learn.mindset.co.za. And Natasha, I see that you made it to the final teachers list.
Well done to me, yay.
Well done to you, like a very well done to you. So Mindsetters, please vote for Natasha simply by going onto our Facebook page and liking her picture. So for now, let's take a quick ad break. We'll see you after this. Welcome back from that little ad break, and I hope you guys used it effectively by voting for your favorite teacher or simply liking their picture on our Facebook page. And like I said, Natasha is there, guys. So if you really like what she does for you guys by helping you out, you just have to simply vote for her and like her picture on our Facebook page. Now remember that we also have our Casio calculator competition back, and that is by simply answering the test yourself questions correctly. Now the test yourself questions, are posted on our Facebook page. So all you have to do is just simply go through our timeline, find the link, go onto the question, answer it correctly, and you stand yourself a chance of winning a Casio calculator. How awesome is that, Natasha?
All fantastic and all a game of chance. Hey guys, that's what we're doing today. We're talking about chance, and I mean, who can't love this section? It's all about games. You're tossing coins, you're picking cards, you know, it's all about
Very
games,
interesting.
real life situations. So Queen, if you've said your bit, I think we should carry on straight with our questions.
Let's go.
All right.
Platform is
Okay
yours.
guys, so question 2. We have a bag where there are 15 sweets. 7 are wrapped in red paper, 6 wrapped in blue paper, and 2 wrapped in black paper. First question, what is the probability of choosing at random a sweet wrapped in blue paper? All right, now remember you've got 15 sweets to choose from. Okay, we're going to just highlight the important information here. 7 of them are wrapped in red. Then you have 6 wrapped in blue paper, and I don't have a black pen and it wouldn't show up anyway, and 2 of them wrapped in black paper. All right, so we're looking at the probability of choosing a sweet wrapped in blue paper. And remember in the beginning we showed you that the probability of getting whatever you're looking for, whatever event you're looking for. So here we're looking at the probability of choosing a blue paper or a blue wrapped sweet. Okay, the probability of getting a blue wrapper is going to be the number of favorable outcomes, and the number of favorable outcomes we have here. How many sweets are wrapped in blue? Well, they said 6 of them are wrapped in blue. So it's your number of favorable outcomes over the number of possible outcomes. So you put your hand into the bag. There are 15 different colors you can choose from. Of that, 6 are blue. So therefore the probability of getting a blue wrapper is going to be 6 out of 15. Okay. Part B. What is the probability of choosing, again at random, a sweet wrapped in black paper? Okay, so now we want the probability of getting a black wrapper. Okay, so a sweet wrapped in black paper, that is. So what is the probability of choosing that? Go back to what you were given. It's your number of favorable outcomes. How many sweets are there wrapped in black paper? There are 2. And again, you put your hand into your bag, and there are 15 sweets to choose from. We're assuming here that the last sweet doesn't have a bearing on the next one because they didn't say that it does. So therefore, it's going to be 2 favorable outcomes out of 15 possible outcomes. So therefore, the probability of getting a black is going to be 2 over 15. All right. And then the last one, part C. Now they're giving you a little bit more information. They're saying, assuming you were successful in choosing in part B, you were successful and you chose a sweet that was actually wrapped in black paper. Now remember, you had 2 to choose from that were wrapped in black. What is the probability of choosing a second sweet wrapped in black paper from the sweets that are left? So this one takes a little bit more thinking about because something's happened here. So in part B, you put your hand into the bag and you pulled out one of those 2 sweets that were wrapped in black paper. All right? So you've pulled that out. 2 things have happened. Okay, firstly, the number of sweets overall in that bag has decreased because remember, you've pulled one out and you've eaten it, it's gone. So therefore, instead of there being 15 sweets in that bag, there's now only going to be 14. But also, you no longer have 2 black wrapped sweets to choose from. You only now have 1, because remember, you've already eaten the other one. So therefore, assuming you were successful, then the probability of getting a black wrapper now is going to be 1, because we've only got 1 black wrapped sweet left out of the total number of sweets left, which is 14. So 1 out of 14 will be your probability. So obviously a decrease because we have taken one of those out of the bag. So now you've only got 1 to choose from this bag of 14. All right. Okay, guys, hopefully you all followed that with me, question 2, and we're going to go straight into question 3 if Queen doesn't have any questions for me.
No questions.
Oh, good.
Yes.
All right, guys, so let's go straight into question 3. Okay, so we're told here that in one bag there are 5 cards numbered 1, 3, 5, 7, and 9. Okay. In another bag there are 4 cards numbered 2, 4, 6, 8. So it looks like we've got 2 bags, one with odd numbers, one with even numbers. You then take out 1 card. 1 card is drawn at random from each bag, and the values of the 2 cards are added together. All right. They say part A, use a table to list all the possible outcomes, all the possible ways. And what we're going to do here, guys, is if you draw out 2 cards and you get the numbers 1 and 2, that's going to be the same as first getting 2 and 1. So we're going to say that it happens at exactly the same time. Okay, so the order is not important here. So in one bag there are 5 cards numbered 1, 3, 5, 7, 9. So in my table, I'm going to put down 1, 3, 5, 7, and 9. Okay, those are the cards in the one bag. And then the other bag has cards 2, 4, 6, and 8. Okay, and they want all the possible outcomes. Well, you've got 1, 2, 3, 4, 5 odd numbers and 4 even numbers. So the total number of possible outcomes, well, it's going to be, in the first case, you can get the number 1, and then from the second bag you could get 2, and I'm just going to go down my column and list all the possible outcomes. So remember, we're choosing these numbers at exactly the same time from both bags. So you can get the numbers 1 and 2, or you could get 1 and 4, 1 and 6, or 1 and 8. All right. Moving to the next column, I can choose the card numbered 3 and then maybe get 2, or I could get 3 and 4, 3 and 6, 3 and 8. All right. If we chose 5, same thing, we can get 5 and 2, 5 and 4, 5 and 6, or 5 and 8. And you get the idea. We simply fill the table in according to our columns and rows. 7 and 6, 7 and 8, and then the last one, 9, 2, 9, 4, 9, 6, and 9 and 8. All right, so if you have a look, we've drawn our table with all our possible outcomes. If you were to count the number of outcomes here, well, it's a 5 by 4 table, so therefore there should be 20 possible outcomes, and if you count them, there are 20 possible outcomes. All right. Now let's get into the meaty part of the question, the probabilities. Part B, what is the probability that, number 1, the sum is an odd number? Okay, so this is going to be a bit of interesting information for those of you who haven't realized this, who have never come across this kind of thing before. When you add the sum of an odd and an even number, your answer will always be odd. you're always going to get an odd answer. Okay, so if you add the sum of an odd and an even number, you're always going to get an odd answer. So therefore, and you can try it with anything even beyond this table, so therefore, what is the probability that the sum is an odd number? What do we say? If something will always happen with certainty, then the probability is going to be 1 or 100%. It's always going to happen. And as I said, you can test it with any even and odd number you want and it will work. All right, so the probability that it's an odd number is going to be 100%. What is the probability that the sum is going to be 13? This is part 2. Okay, so let's go through our table, and there are patterns to follow, but let's just do it from our table. We want the sum to be 13, okay? So go through your table, and you're obviously not going to take things that are going to give you a sum less than 13. So we're not even going to bother with that last outcome there in that row, 9 and 2. That's only going to go up to 11. 7 and 4 is only going to go up to 11. Okay, so we're going to look at ones like that. 9 plus 4. 9 plus 4 is 13. That one, and you can see it's a diagonal pattern. 7 and 6 is 13. And 5 and 8. If we add those numbers together, if we add those two cards together, our sum is going to be 13. All right, so it's 9 and 4, 7 and 6, 5 and 8. So therefore, we've got 3 favorable outcomes out of a possible 20. So therefore, what is the probability of the sum being 13? So the probability of the sum being 13, or the probability of getting 13, is going to be 3 out of 20. All right. Okay, let's move on to the next one. The last one. What is the probability that the sum is a multiple of 5? Okay, so now guys, again, what I said to you before, you need to understand all the stuff you've done before. Factors, multiples, prime numbers, all of that. You never know where you're going to be asked a question about them, okay? Multiples of 5. That means 5 can divide into those numbers. So we want the sum to be a multiple of the 5. So when we add these numbers together, so for example, if I look at the first outcome here, the first element, 1, 2, if I add them, I'm going to get 3. Obviously, 3 cannot be divided by 5, so that's not going to be a possibility. So we're going to go through the table again, and we're going to look for sums that, when you add them together, that sum can be divided by 5. All right. So if we look at row 1 here, where 2 is what we've drawn out from the bag, okay, we've got 3 and 2 as a possible outcome. Now if you think of, add that up, 3 plus 2, if you think about that, 3 plus 2, 5. 5 divided by 5 is 1, so therefore that will be a possibility. All right, so that's basically what we're doing. We're looking through the table, adding the numbers up, and then looking at the answer, and then saying, can that answer be divided by 5? Okay. All right, so if we go through the rest of the table, so if I look at 5 and 2, that's not going to work. 5 plus 2 is 7. 7 and 2, 9, that's not going to work. All right, I'm not going to do all of them. I'm just giving you an idea. 9 and 2, that sum, if I add it together, 11. 11 doesn't divide by 5. However, I'm going to take that off because that was not one of our possible answers there. So this was 7 and 2 and 9 and 2. All right, however, if we look at this one, our second element here, we've got second row, so we're looking at this one, second row, first column. All right, 1 and 4. 1 plus 4 is 5. 5 divides into 5, so therefore that's another possible answer. All right, if you carry on across this row, you will find that none of the other ones, do they work, don't they work? none of them work. This last one here was 9 and 4. 9 and 4 is 13. So remember, that's not going to work either. All right, come down to the next row. 1 and 6, 3 and 6, 5 and 6, 7 and 6. None of those work, but have a look at this one. 9 and 6. So if you draw card 9 and you draw card 6, 9 plus 6 is 15, and 15 is indeed a multiple of 5. So that one's going to work. We come down to the last row. 1, 8, 3, 8. That doesn't work. 5, 8 doesn't work. But 7, 8 does work. All right, so therefore 7 plus 8 gives me 15. 15 can be divided by 5. So how many favorable outcomes are there? We've got 1, 2, 3, 4 out of a possible 20. So part 3, the probability of getting a multiple of 5 is going to be 4 out of 20, which you can simplify to give you 1 over 5. All right, so 4 out of 20 or 1 over 5. Remember, with your probabilities, you can leave your answer in fractions, in decimal form, or as a percentage form. Okay, any one of those answers would be acceptable. All right, so Queen, it looks like you're dying to ask me something.
Yes, we've got a question from a lot of mindsetters actually. The one wants to know, Tendo, he wants to know, do the diagonal numbers always give the same answer?
The diagonal numbers do. It is actually a pattern. It is a very special table, and the diagonal numbers will always give you. I mean, you can take any diagonal. I mean, even if we look at this one, all right, 5 and 2, 7, 3 and 4, 7, 1 and 6, 7. And it does work with all of them, guys. So if you're going diagonally from right to left, they will always work. All right, if you go that way, let's do one more just to prove our point. If we go 7, 2, 5, 4, 3, 6, 1, 8, all of those ones will add up to give you 9. So that is well spotted. This is a special table, but I don't want to go into patterns and that, because remember, our lesson is on probability. So if you do see the patterns, good for you.
Okay, and it also seems like a lot of mindsetters would like if you could please repeat question 2C.
Question 2C. All right, so we all good with the table question.
Yes.
Let's move back to question 2C. Oh, okay. So this one was a little bit confusing because we drew something out of the bag and we didn't replace that something. Okay, so here we took something out of the bag, and in this case it was a sweet. So we ate it, or we gave it away, or we did whatever we did with it, and so it's no longer part of your bag. So what happened here, just let's go over the question quickly again. We had 15 sweets originally, 7 were in red wrappers, 6 were wrapped in blue, and then 2 were wrapped in black paper. Okay, so the part where you guys, some of you seem to be struggling, is now assuming you were successful in choosing a sweet wrapped in black paper, which was part B. What is the probability of choosing a second sweet wrapped in black paper from the sweets that are left? Now guys, remember, whenever you work out the probabilities, I've shown you this before, the probability of any event is the number of favorable outcomes over the number of possible outcomes. All right. In part C, let's list our number of favorable outcomes. So how many sweets were there with black wraps or wrapped in black? I don't want to say black wrappers because it almost talks like I'm talking about music or something. But how many sweets were wrapped in black? Now remember, they said you were successful in part B. So in part B, you actually drew out a black sweet. All right, there were only 2 wrapped in black paper. So therefore, if you've already drawn one out, 2 minus 1, that means there's only 1 left over. All right. And then if you look at your sample space, okay, you've taken one of the sweets out. So there's now only 1 of these, okay. So how many are you going to have altogether? You've still got 7 in red. You've still got 6 in blue. So that's 13. But now you've only got 1 sweet wrapped in black. So 13 plus 1 gives me 14 as the new number of sweets in my sample space. So therefore your new sample is going to be, if you list all of them down, red papers all the way, and then you do all the blue papers, and then you list all the black, where there's only one. If you add everything up, you're only going to end up with 14 because 1 is now missing. All right, so the number of black sweets that are left is 1. The total number of your sample space is 14. So therefore, if we go back to this, the probability of now choosing a sweet that's wrapped in black paper is going to be the one sweet that's left over divided by the total number of sweets in the bag, which is 14. So it's the one black sweet that was left over divided by the total number of sweets, which has now been reduced from 15 to 14. Hopefully that's answered those of you that were a little bit confused. Hopefully that's helped you out with that problem. Anything else, Queen?
No, that is it. So I think it's time for an ad break now.
Yes.
Yes, I'm sure you mindsetters just quickly want to take a little break. So we'll see you after this. Let's go for the ad break. Welcome back, Mindsetters, to the last segment of the show. And we see that you guys are actually very active on our social media pages. You guys are helping each other out. Remember, that's what it is all about. We're trying to create a community of Mindsetters where you guys can get to help one another out. But Natasha, it seems like we had one more question from Tristan, and he asks, when they ask us to write down all the possible outcomes, aren't we supposed to add the 2, like the question says, instead of listing the numbers?
So he's talking about question 3 here, and it's part A, where they say use a table to list all the possible outcomes. Now, guys, what I did in this table is, you noticed, because what they're actually saying to you is, yes, eventually the question asks you about adding the numbers together. But they're saying to you here, when you draw cards out of these bags, what are your possible outcomes of cards that you can draw? So what I've represented in your table is the possible outcomes of the 2 cards you can get once you've pulled those out of those bags. So if you pull the number 1 out, then you could pull the number 1 and 2. So this is what that means. Then if you pull the number 1 out, you could possibly get 1 and 4, or you could get 1 and 6, or 1 and 8. So those are the possible outcomes of the draw that is taking place. Okay, so in this part, we haven't started adding yet. In this part, we're just listing the possible outcomes when you put your hands into those bags and you get out those numbered cards. All right, hopefully that makes sense to you. And then it is from there that we can then deduce the other probabilities where we've got to add the sum together. All right, hopefully that helps him out, Queen.
I hope that you got your question answered very clearly, Tristan. And do we have time for one more question?
We might do. I do want to get into the challenge question, but
right.
Let's quickly see.
Okay, Ronewa would actually like if you could repeat question 1, number B.
All right.
Maybe we can.
Okay, I think what we're going to do is let's first go on to our challenge question, because I'm sure it is one that many of the students have already tried to answer. And then if we have time, we'll go back to question 1B. All right. So this is now our challenge question, which was posed to you guys at the beginning of the show. We've got the names of each of the 12 months of the year, January all the way to December. They're written onto 12 identical cards. The cards are then placed in a box, so a box this time, not a bag, and the box is shaken. Okay, that's to ensure that everything's mixed up nicely. You then draw out a card and you replace it. Okay, so every time you take a card out, importantly, your number of elements is staying the same. It's still going to be 12 each and every time, because each and every time after you draw, you're putting that card back in. Okay. Part A says, write down the sample space S in set notation. Okay, so your sample space is going to be all the sets. So this is part A. And we want the sample space of this experiment. All right. So what are we going to get out? All your possibilities. Well, you can get, remember, it's numbered. Well, it's on this cards. You've got 1 to 12 cards, and you've got all the months of the year. So it's going to be January is a possible outcome, February, and there's going to be 12 elements altogether. March, April, obviously you guys know the months of the year, so all the way April, May, June, July, August, September, October, November, okay, which is where we are heading, and December. Okay. Now guys, you'll notice what I did is I actually wrote them out, even though they were abbreviated. I didn't just write J, F, M, A, M, because M could stand for either March or May. So it's important that you actually list the elements that you're working with here. All right, it's not sufficient to just write the first letter of the month. Okay, part B says write down a set to represent the event A, which is drawing one of the first 6 months of the year. Now remember, 6 months, where are we going from? January to June. Okay, 6 months. 1, 2, 3, 4, 5, 6. The first 6 months of the year. And this is our event, which I've forgotten. I think they called it event A. Yep. So event A is going to be the event that you draw one of the first 6 months. So Jan, Feb, March, April, May, and June. So those are your first, that's event A. All right. Let's go back up there. That was part 1. Part 2 says event B, you draw a month beginning with the letter J. Okay, so now event B is we draw a month with the letter beginning with the J. Now guys, look at your sample space. You have January, June, and July to choose from. So there's 3 different months beginning with the letter J. So Jan, so event B is going to be January, June, and July. So 3 elements in set B. All right. Event B. Part C says represent your sample space A and B by means of a Venn diagram. Now, whenever you draw your Venn diagram, you usually have to draw, well, you always have to draw a box to enclose your elements. So we start with a rectangular box that's going to enclose our elements and show the entire sample space. Okay, we've got 2 events. Now guys, we always represent these as circles. Okay, you know, some people will say, can I draw triangles or whatever? Doesn't really make sense. Circles are what are you used to. Stay with the shapes you're used to. Don't get yourself confused. You're going to represent these events A and B. Now remember, we've already listed events A and B in parts B1 and 2. So all we're going to do when we draw our 2 circles is we're going to, in those circles, put down the elements from these 2 sets A and B. All right, so let's do that on our diagram. So we've got our block to represent our entire sample space S. All right, and then we've got 1 circle to represent A, and then we're going to put another circle in to represent B. You then have to determine, do these 2 intersect, all right? Because we need to know how to position these circles. And you see that the first 6 months of the year definitely intersect with choosing a month starting with the letter J, which is part event B. So definitely A and B do intersect. So that means that when I draw these two circles, they need to intersect. All right. So we've got event A, event B. The first thing you should fill in is your intersection. Okay? So we want the intersection being a month starting with the letter J and falling within the first 6 months. So a month starting with the letter J and falling within the first 6 months. That's your intersection. So your intersection here is January and June. So therefore, I'll just make this a little bit bigger so we can write that in. All right. So January and June are going to be your intersection of events A and B. All right. What are the other months that we've left out of event A? Remember, event A was having the first 6 months of the year. So we still have to put in February, March, April, and May. Okay, so I list that. February, March, April, and May. Okay, and then in B, it was a month starting with the letter J, so we've already got January and June. Therefore, the only one that's left out from our set is July. All right. Remember, however, guys, I said to you, you need to represent the entire sample space. So you've got to look at this, and you've got to say, well, is this a true representation of my sample space? And the answer is no, because all you've got are the two events A and B. What about all the other months? So you also need to represent that in your Venn diagram. And you put those outside of your two circles. So you're going to put it in the space, in your little square space, outside the two circles to represent everything else that's not in event A and B. All right? Remember, there were 12 months to choose from. So we've got Jan, Feb, March, April, May, June, July. So we've got August, September, October, November, and December. It's 1, 2, 3, 4, 5. 5 elements that are neither in events A or B. And I think that we are actually running out of time, but we have done the most important part of this question, which is draw the Venn diagram. Because really, guys, you can answer the rest of the questions based on this Venn diagram. Once you've got it correct, the probability parts really become quite simple. All right, so with that, Queen, I'm going to cross over to you. I don't think we have time for questions, so I'm going to say goodbye.
All right. Thank you so much, Natasha. Thank you for everything that you have done for us. Mindsetters, I can see the love that we are getting for Natasha. Everybody just loves you. And we've got a message from Salai, who also says Tasha is the best. So I'm hoping that you guys are not only saying it, but you're also liking her picture so that she can also get to earn herself a little something for the Get Connected competition. So, guys, we also have one more shout out for Umandela Lucky Mpati, and he's a grade 12 mindsetter, and it's his birthday today. So a big happy birthday to you, Mandela. Hope you enjoy it and hope that you've been having a great day thus far. But mindsetters, for now, it is going to have to be goodbye as we wrap up the show and say goodbye to all of you. Remember now that we can still find us here, same time, same place next week on a Monday for the Grade 10 Mathematics show. So do not despair. We will be back for you, and we love you. So it is love and peace from me. Goodbye.